Welcome back to 5.2. This is the third part. And so for this next example, number 70, they'll show this method in the book, but I want to demonstrate it here as well. When it's messy on both sides, um, I typically will work one side, work the other, and see if they converge. And so one thing I do not like about the left-hand side of this problem is, from an algebra standpoint, I never did a trinomial squared. I never was able to factor a trinomial squared. So it's going to be pretty hard for me to show that the right hand side could be written that way. It's possible to work this left hand side and then factor down to the other as well. But I'm going to definitely show it with one side being worked independently than the other, just so you know that that's an option. And again, that would be spelled out in the book as well. So let's look at this first one. I'm going to first work this side. I'll call it side number 1. So here's number 1. We're going to take 1 plus sine x plus cosine x, and we're going to multiply it times 1 plus sine x plus cosine x and see what we get. So you know what we're going to get, 9 terms. Here's the 9 terms. 1 plus sine x plus cosine x, running the 1 through. Now let's run the sine through, plus sine x plus sine squared x plus sine x cosine x. And then let's run this cosine through, plus cosine x plus cosine x sine x plus, be careful not to touch the side, cosine squared x. We get a big mess, right? Let's see how it simplifies. Let's see if we have any like terms that we can combine. Looks like we do. We have this 1. Usually our experience is the biggest and the smallest don't match. So we got this 1. And then how about sine x? Let's go find them. This sine x and this sine x can come together for 2 sine x's. Apologize, not that sine x. I didn't see that one the way it was. It is this. These 2 sine x's can come together. We also have some cosine x's that are by themselves, cosine and cosine. So we're going to have a couple of cosine x's. We're going to have a sine squared that doesn't look anything like it, but let me highlight these guys in green. Whoops. Let me get the highlighter in green. This one and this one are the same, right? It doesn't matter what order we multiply. And so we do have plus 2 sine x cosine x. And then we have plus sine squared x plus cosine squared x, which can't combine algebraically. So now we'll use some trig. What do we know this is right here? Sine squared plus cosine squared. We know that that's 1. 1 plus 1 is 2. So now we have 2's everywhere. We have 2 plus 2 sine x plus 2 cosine x plus 2 sine x cosine x. And so let's factor out the 2, and we have 1 plus sine x plus cosine x plus sine x cosine x. Now we could keep trying to manipulate this one, this four-term thing. However, what if we just parked that? What if we remembered that that whole left-hand side worked out to be like that, and we multiplied out the right-hand side? So let's look at number 2. So number 2 is on the right-hand side. So number 2 there. So number 2 says, here's the 2. That's the same 2 that's there. Well, let's just multiply that out. 1 times 1 is 1. 1 plus cosine, or 1 times cosine is cosine. Sine times 1 is sine. Sine times cosine is sine x cosine x. And look, they match. We worked them independently and got them to the exact same level. The 1's match, the sine x matches, the cosine x matches, and the sine x cosine x matches. You know it doesn't matter what order we add things in. And so everything's a perfect match, just so you know that that's an option. However, if you work it like an equation, I can't give you credit for it. You have to work from one side to the other. Sometimes problems can be deceiving. Even though they look small, they can be big, and even though they look big, they can be small. So if we look at something like 76, it condenses down to cosecant squared x. Well, we're going to be working that left-hand side in order to make it look that way. So the one trick is put everybody in sine and cosine. Let's see if that works here. So if we have sine squared x, 1 plus cosine x over sine x, plus cosine squared x times 1 minus sine x over cosine x, and then plus cotangent squared. Maybe I'll just leave the cotangent squared and see if we can do something special here. So here's what I have. I have sine squared x plus cosine x sine x plus cosine squared x minus sine x cosine x plus cotangent squared x. Okay, so what is sine squared plus cosine squared? Oh, that's 1. What is positive cosine x sine x minus sine x cosine x? Well, those go away. And that's an identity. And we're finished. So the reason why I did these ones here in sine and cosine was because there was some multiplication going on. There was no multiplication going on with the cotangent, so I just left it, and it turned out to be the great thing to do in there. And then last one, we need to make sure that these two guys are the same, or that I could work from one to the other. I would work from this side. You know how this factors: sine theta minus cosine theta. Oh, sorry, plus cosine theta, because there's a plus in the middle, times the first thing squared, plus, I'm sorry, not plus, minus, right, because it's got to be the opposite sign, so the middle garbage cancels out, minus the product of the two, plus cosine squared theta. So if you're saying, I don't know what you just did there, then you need to go back to your Algebra 2 teacher and ask, why didn't you show me how to do this? Because it's part of the curriculum. This would have been x plus y. And then you square, change the sign, and square. That's how you factor cubes. Or better yet than going back and complaining, just go memorize how to solve it, because it's used a lot. Always squares, always positives on the squares, and all of that. So this is nothing more than stuff that you brought with you, nothing that's been taught in this class. But I brought it up on the factoring review and stuff. And so we're hoping with just a quick memory jog, you'll be fine. You're done. What's sine squared plus cosine squared? This is the trig part. Everything else was algebra. You know what sine squared plus cosine squared is. It's 1. And you have the right hand side. Done. You're done in that regard. You have it. Now, I know that some things are out of order, but order doesn't matter. You're not in multiplication and not in addition, so you should be comfortable leaving it like that. I'm not going to make you flip it, because we all know that that's the same thing. So these are really good character building problems. You know what you're shooting for. So if somebody is having questions about this, what I'd most likely ask is for you to send me a picture of what you've tried, and then I would guide you off of that picture, because I can go through the problem with you and you can follow it, but that's going to be dangerous ground. You want to be able to come up with these ideas yourself. So the book and I are modeling how to do it, doing lots of examples, right, from different stuff. So in the course of the 3 videos, we've done lots and lots of examples of this stuff, and there's even more in the book, and there's even more online, right? You can watch trig identities being done. So this is a really good exercise for you. So spend a lot of time in here, get it done, and get good practice.